Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today I'm going to continue working on the Ghidra, the Ghidra static analysis bug finding tool. And what I'm going to be doing today is writing a check for Sprintf. And actually, let me go ahead. I'm just going to write a quick test case for Sprintf. Sprintf. It's just so I could show exactly what I mean and what I'm looking for. Okay, let's get rid of fgets. It's going to take a second for me to write this test case. Okay, now let's go ahead and write this. So this test case, what's going to happen in it? First, it's going to scan in data into target. Let's make this the first buff 500 bytes, and the second buff. Actually, I'm going to name this to input, and this is going to be named to target 100. And let me show you what I mean. Sprintf target is the destination, %s is the format string, and input. So right here, what I mean is I'm going to be looking for sprintfs where the format string is %s, because then it's writing as much data as to the buffer as how should I phrase this? It's writing basically the entire string of the input to the destination without any regard for the size constraint of the destination. So that's what I want to write a check for. Now, what is that going to involve from the perspective of Ghidra? Actually, first I'm just going to compile this. I'm going to change this text message to so I know that I'm not, by some smooth brain mistake, working with a previous version of this test case since I copied and pasted it from another one. Okay, let's go ahead and make this and run it. Okay, we are getting the new print message, and with this input, it should crash it. Hang on, this didn't crash it for some reason. Oh, it might be. I think I know why. Let me guess. $270. OX200. Okay, so the buffer that we're overflowing is RBP minus 0x270, whereas the buffer that our input is being stored at is stored at RBP minus OX200. So we would have to give it a large enough string that it would overflow both the target buff and the input buff. That's why it's not crashing. Okay, cool. But yeah, so you guys can see what I mean about this exact check. Let's get to actually trying to write a check that will detect things like this. Also, one thing I just want to emphasize again while I'm writing this, the purpose of this tool isn't necessarily to like confidently find bugs. It's more or less just to like narrow down the areas we have to search to areas with a higher probability of it being a bug. And I'm going to go ahead and copy this over. Basic sprintf 000. Okay, I'm just going to copy and paste this command so I don't have to retype the entire thing. And I will, since this is the first time I'm working with this this binary. I will need to import it. What is it? Sprintf 000. Let's give it a second to run. Okay, that was good. Let's go ahead and start writing the check. For that, what first I'm going to do is add sprintf to the functions that I will check. Sprintf 4. And then let's add it to the switch statement. I should really change these from like just numbers to actual like constant variables with names, because it's going to cause some confusions if I just leave it as is. Func to analyze reference break public void analyze sprintf function to analyze reference ref. Okay, I'm just going to have a print statement here just to verify that this check is running. Okay, let's run it. It should print out the string like a sort over Damocles. What? Oh, I'm importing it. Need to process it since it's already been imported into the project. And let's see, is it gonna run? Yep, okay, so this check is indeed running. Cool, what I'm gonna want to do next. Actually, public void sprintf per. Since the model of how I'm doing this is effectively writing check functions, and when I specify a function that I want to, or like a check for like a particular function, like let's say memcopy, all it's doing is just calling the check functions. I'm just going to go ahead and write the particular check function that I'm doing. Function to analyze reference ref int format string arg, and let's go ahead and move this string over here and just make sure that we are calling it properly. So for this %s, that's the name of the check, %s, function to analyze the reference, and this third argument here, that is the how should I want to say this? It is the position of the format string argument in sprintf. So looking at sprintf, so yeah, right here we can see that the format string argument is the second argument. For s in sprintf, it's the third. For vprintf, it's the first. So we just have that argument there, so we can use it for multiple different functions. That it has effectively the same check desired, just different argument position. Okay, also, with my method, I'm specifying that the first argument is 0, second argument is 1. It's 0 index, that's why for the second argument I put a 1 there. And let's just make sure that this runs. I think I already checked to make sure that this runs, but I just want to double check. Okay. Good thing I checked. Okay, cool, so that's working. So for the next thing is, I'm just going to copy and paste this code again. Once I write just a few more checks and get a better idea of exactly how I want my checks to be structured, and I'll probably be offloading a majority of this to helper functions so I don't have the same code copy and pasted a bunch of times. And what do I want from here? I want to get to the P code that is actually making the sprintf call. All of this code up here will do this, so I should just be able to add a print statement here, and that should, yeah, that should give me the P code that is actually making the code, well, making the sprintf call, I should say. Let's run it. Okay, this is making a call that looks like it is sprintf. Okay, cool. So we have the call here. The question is, how can we get the string? Because effectively that's the entire check right there. This var node right here is the second argument to sprintf, and this is the var node that we are interested in. So let's go ahead and get that var node. Var node format var node equal. Oh, we already have. Okay, I just made a smooth brain mistake. I already have what I was wanting. Okay, var node format var node equals inputs format string arg +1. We have the +1 since the first argument to the P code is the function being called. And I'm just going to go ahead and print this var node just to make sure that we're getting the right one. Format var node. Okay, cool. So how do we want to do this? I'm gonna take a look at the Ghidra API docs for var node. Okay, cool. You just can Google Ghidra var node, and this is the Java page. Let's see what we have here. Actually, let's take a step back. The argument that it's taking as a form of string argument from the perspective of the binary is an address to a string. Can we? I think the best way to go about doing this is to first get the address and then see. Ghidra probably has some functionality for like get string at a certain address. So the first thing I'd probably want to do is do a check with is address to verify that it is an address. And then I believe we should be able to use either get address or get offset. One of these two should give us the actual address that we want. And then from there we can see if Ghidra has some functionality, like get string at certain address. So let's go ahead and start writing this. How do I want to do this? If format var node dot is address, if it is not an address, we will return, meaning that if it gets down to here, it is an address. And at that point, let's print get address, and let's also print out get offset. And let's run it to see what happens. And at this point, I think it would be helpful to actually open up the binary in Ghidra so it can reference what's actually going on with the results. That should probably provide some assistance in a few areas for just verifying that Okay, let's analyze it. And let's jump to main. Cool. So here's Sprintf. Okay, cool. Looking at here, we can see it's printing off our address or offset, which means the var node is not an address, so, or at least from the perspective of like dot is address. Let's change this to is constant. Let's see if this will work the way we want it to. Nope. I'm just going to try commenting out this check altogether. So we see that we were able to, when we commented out the check, we were able to get the address and the offset, which from what it looks like, yeah, it looks like these two numbers are the same. So in the Ghidra API, they have their own custom data structure for addresses. And that's what this is. And it looks like the offset is effectively just the numerical value of the address. And when we take a look at this, oh wait, no, it doesn't take base 10, at least like that. What? This is weird. 10201F. Okay, this is weird because when you look at %s, the string, we see that it's stored at this location, 10201F. However, when we look at it here, we're seeing something completely different. So, don't you know what I think is going on? I think what's going on is this. Similar to how when we're looking at like the fgets, and we're like trying to determine if something is, what is it called, a stack buffer, we would take the var node, we wouldn't look at that var node, we would look at where that var node is defined, and that would tell us. I wonder if this is a similar situation. So for this, let's look at format var node.get def. This will give us the P code at which the var node is defined, and hopefully that will tell us what its value is. Oh, okay, so this is this right here is telling us that it is established at offset 10201F, which if we take that, oh wait, I had a comment in there, that's %s, cool. So it's like what I thought, it's the same, what's it called, same, yeah, same, effectively the same problem. So for this, I'm going to basically rewrite this function, but if constant, gonna remove the check for if it is a stack buffer or a register. Let's see what this is doing. We don't need this. That was for something else I was trying to do, but turns out I didn't need the stack string return val or iterate through each var node of the definition of constant. Yeah, and get var node def constant. I'm just going to call this get var node definition value. So let's go down here. And let's do format var node. This hopefully will give us the offset of the, give us the offset OX10201F. Something is going on here. Parent func. Oh, yeah, function parent func. The reason why I have the first argument being parent func, even though I don't need it, is when I was initially trying to make that functionality, I was trying to do it initially a different way because I was still just trying to figure out. And we see here it's printing out this address. What is it in hex? Yep, 10201F. And Ghidra interprets what you put in here as hexadecimal, as we are about to see. So when I put it in a base 10 number, interpret it as base 16, so I thought it was something different. But we see here it is actually able to give us the offset, so that's cool. So we're able to get the offset or the address of the format string argument. Now all we need is, what do you call it, the functionality to like get string at. For this, not too sure, but I'm sure we can figure it out. First off, what I'm going to do is I'm going to just do a few greps through, what do you call it, the Ghidra like example scripts, which can be found under like the Ghidra directory, Ghidra features. I'm just going to do a few just guess greps to see if I can't like find something in string at def get string at address. This is exactly what we're looking at. Let's take a look. Get string data equals get data at. Okay, let's take a look at get data at. Def get data. Is that just, hang on a second. Ghidra get data at. Oh, okay, you literally just call it like that. Okay, it takes an address. So, looking at this example, so this get data at, it isn't a custom function that is defined here. It is actually part of the Ghidra API, and it looks like they just flat out call it. So I think we can effectively just call that function at first. Looking at it later on, we can see that it does check to make sure that it is a string and returns it. So let's try to write that functionality. What we'll first need is we'll need the ability to turn our offset into an address, because from the Ghidra API, those are two different things. So I wonder if I can just do something like this, where we're printing it out. It would make sense that we could make a new, what do you call it, a new address by just calling the address method or class, not too sure on the semantics there, and just pass it an argument being the offset, but it appears that that is not what we're able to do. Next up, get address. I would believe that they would probably have some like is it? Some function like get address at get address vtable address. I'm just going to take a look at here. Actually, I'm just going to Ghidra get address. Address dot creates a new address by parsing a string representation of the address. Let's try that. Although right now this is not a string, it's a long, I believe. So might give us a type error for the argument. But if that is the case, then we can just convert it over to a string hex representation, just pass it in, no problem. Error 105. Yeah, I get the feeling it's that line right there. How can I'm just gonna Google real quick how to like convert like an integer into a string hex. I'm gonna pause the video for that. Okay, I'm back. I fixed the problem. Effectively what I did is I remembered that var nodes, in addition to the .get offset method, also has the .get address, which will just give us the address which we're looking for. So I just called that instead of get offset. So now that we have that, we can, let's try the get data. If I recall correctly, this is how the example called get data, so let's just do it in that way and hope it works. Cannot find symbol get data. Oh boy, that's not how it worked. But luckily we have a ton of examples, so block.get data. Wait, was it get data at? Oh yeah, I think it might have been get data at. Okay, yeah. You see right here get data at address, so let's try get data at. And while that's running, I'm just look for other examples in the likely case that we got this wrong. No. Okay, so we ran it and it returned null, which means we're doing this wrong. The question is, how can we do this right? Data. No, let's look at the get string function, because that's effectively what we're trying to do. So let's see what is going on there again, and see if we can't get data at. So one thing I just noticed, this is a Python function, which might be part of why they are calling it differently, or they're calling it without like any like something dot that. So API, all of these are saying like API dot get data at. So let's try to emulate that. For that, I'm going to open up this and see what API is set equal to. I failed at copying and pasting. Okay, I finally did it right. API equals. Can we just do API dot? Okay, let's try running this as we try to see if we did this right. Hang on. No, it did not. Okay. API equals. Extra utils. What is extra util sit equal to? So here we see that it's just calling get data at without anything. Microsoft code, I know. Yeah, that's Microsoft. I'm not going to deal with that. Might be some weird thing happening. So program.getListing. I want to see all the mentions to API. This dot API flat program API dot. So billion. We see that it establishes an API. Is that all we have to do? Let's try this. Flat program API. Is this all we have to do to actually access and get data at? API might not have been initialized. Okay, so there's some initialization we have to do. I was very skeptical if I was pretty sure that there was some initialization we'd have to have done. But let's see. API. API. Get function at. Why? I'm going to take a look at the other examples of get data at, since this one isn't. Actually, let me take a step back. Let's take a look at the trusty. Let's take a look at the trusty docs. Current program. Current program, that might be what we're looking for. I know that's kind of a constant used to signify the current program, and I've used it successfully before and it made stuff work, so let's try it here. Current program. What is the data type of current program? Protected program. Is there... Okay, so it's a program, not a flat program API. Is there a method that will return a flat program API? It's not looking like it. Okay, yeah, that's not happening. Fields, flat. Oh, wait. Is there a better way to do this that I'm thinking? What does a data manager do? Probably just organizes the memory, not what we're looking for. Yeah. So, what am I looking for? I'm looking for get data at class recover. This, hang on, I'm gonna look at this real quick. Get data at other listing. What is other listing equal to? Dot get listing. Let's try that. Program. What does listing give us? Okay, this might work. And it didn't. No, I'm just gonna double check that the address that I'm passing it is indeed the correct address. Yep, constant. Maybe I'm just gonna try something. Get offset. Probably is going to crash it, but long shot here. Okay, cool. So since this video is approaching 40 minutes long, I'm just going to pause it and then I'll come back when I actually figure out what the solution is. Okay, I found the error, or the fix rather. So instead, actually, basically, if I get the offset to the address and just reconstruct it, Ghidra is then able to get the string. So then let's do this string now equals x dot get value. And let's see if this works. String. Oh, I forgot semicolon. But yeah, while it's running, effectively what I'm doing is current program dot get address factory dot get default address space dot get address will construct an address if I string get value. How to what was DS? Okay, first off, how did I do it? This current program dot get address factory dot get default address space dot get address. This will return an address if I give it an offset, which I just gave it the offset, and that address that it returns, I am actually able to get the value. Now I have to convert from java.language.object to string. I'm just going to go over that real quick. Java convert from object to string. String.value of. String.value of. Let's see if this works. I'm going to continue looking at this web page from Google just in case this doesn't work. And it does. Okay. And next we should be able to do system.out.println out.contains %s. This should return true. True, and I'm just going to change this to like %t, and this should return false. And if it does, then I believe that's the POC for this check is working. It will need a bit of cleanup, but at least the POC is working. It's false. Cool. So we were able to write like the base of the %s Sprintf check. And yeah, this video is 43 minutes long, so I'm going to cut it here. Thank you, gamers, for watching.